Welcome, Iman. Thank you for the collaboration around our GenAI offer. So let's first start by why generative AI and what business problem are we trying to solve? Obviously, network telecom are becoming very, very complex. And automating operation is absolutely an imperative to reduce the mean time to identify, protect the quality of the network, and reduce the OpEx. Applying a machine learning is obviously help, and taking benefits from generative AI in the service assurance analytics bring this to the next level by helping operation team to, one, being able to chat, talk to the network, talk to data, democratize the data, and being able to interact with the data through network analytics by using natural language model. The second thing is helps to easily discover and correlate performance, fault, inventory, and topology data, again, using natural language expression. And finally, it empowers ultimately the operation team to accelerate the mean time to fix issues, to identify issues by simply raising those queries through LLM and not having to open multiple systems to troubleshoot and to get to conclusion. Then Iman will tell us a little bit more about how this works. This is an example of how with AWS, where we work together to empower our fault management system, the NOC operation, through GenAI. NOC engineer receive an alert, doesn't know how to interpret it, and this is where the GenAie come into play. So we have pre-configured prompt defined per alert where the NOC engineer can take benefit of it and GenAie respond. For example, on this alert, the GenAie can respond about the synopsis of the alert, what is the possible causes of this alert, and what are the recommended troubleshooting. So obviously this alert is related to traffic, but the NOC engineer doesn't necessarily know what GenAie has access to in terms of traffic KPI. Based on this, the NOC engineer would like to know about what are the list of KPI available in the system that GenAie can provide. So he has access to the prompt. He interrogates the GenAie about, can you give me the list of KPI available in the system? And the GenAie respond with all the list of KPIs available in the system. So as we can see, number of users, uplink traffic volume, downlink traffic volume, cell availability. From here, the user would like to understand, okay, I have access to the traffic. I would like to see if this alert is impacting my users and the traffic on this area. So simply interrogate the GenAie about how many users are available at this cell at this particular time where the alert occurred. And GenAie respond by providing the information, 44 users are available in this cell and no particular concern about the connectivity of those users. Finally, something that we would like to illustrate is part of this intelligence. There is also interpretation of the topology. And here we are providing an example of how the GenAie can equally assist the NOC engineer to identify not only the surrounding cell, but navigating across the topology, just simply because he has this information and list all the topological link between these cells and the other cells. So this is an example of how this can be translated to the NOC engineer. Having the same information would require him to open multiple systems, go navigate, sometimes create the reporting. So in terms of efficiency, it's obvious that the NOC engineer have a lot of benefits in terms of efficiency. And I will hand over to Iman to tell us more about how is this possible.
Okay, thank you, Paul. So everything starts with the data. So here we received the radio access network data from MyCom WSI network expert team. We worked hand in hand to prepare this data and to pre-process this data. This is very important for the generative AI to be responding correctly to the expectation. So once we prepare the data cross-domain, and here we're talking about performance management data, fault management data, localization of the radio access network cells, we start the first step, which is extraction of the schema. By extraction of the schema, I mean we are taking the name of the databases, the name of the tables, as well as the name of the columns. This is what the model needs to be able to produce the reporting and the analysis afterwards. So this is the first step. And the second step, we need to choose the foundational model, and here in particular the large language model that is suitable to micro-OSI data, performance management and alarm management data. We've used the AWS Bedrock environment with Entropy Cloud 2 that is hosted in this generative AI framework. And with that, the next step is the prompt engineering configuration. And here again, we worked with micro-OSI network expert to configure the prompt to meet the NOC scenarios by means of extraction information from the PM data, from the FM data, but also cross databases to bring the insights to the network operational teams. And the last step is, of course, once the model is getting the schema and analyzing it, once there is a request, this request will be translated into a KPI, a key performance indicator, or it will be transformed into an aggregation between alarming and KPIs, and then it will be translated into an SQL query that will be executed against different databases, and the consolidation is summarized and displayed to the NOC user for their reporting. So this is how it works. So Paul, tell us what is next.
Thank you, Iman. So what is next? Thanks to the collaborative model with AWS, we have a solution today that is proven. Our next step is to bring this to market, and we are working on making this available for all our AWS customers. So please stay tuned. You will hear from us soon. Thank you, Iman, for joining us.
Thank you.